Thanks for coming along. I'm Koch. I'm a geologist at PGS Reservoir. I've been working a lot recently on West Africa, and today just going to look at some data in the Namib Basin and Namibia, kind of moving away from some of the areas that we've been looking at earlier today into some really frontier areas. These are some of the last frontier areas of West Africa. Just a brief introduction. We've been kind of talking about a lot of these discoveries recently, Kamiya, and more recently the Lontrum and Winget discoveries by Cobalt. We've got discoveries by Petroleum in the Benguela Basin here, and then we look at the Namib Basin further to the south here, and there's really only one exploration well, and move into Namibia where there's a few dots here, but there's an awful lot of ODP, DSTP wells here, and there's really only about 15 exploration wells along this entire coast. So although a lot of the exploration has been focusing on the north, where we've got our salt plays, a lot of pre-salt geology going on, we really see the same geology going on here. We don't really see as much salt, but the same sort of pre-salt geology is really going to be here. So the talk is really just going through a bit of a geological history of this part of the margin, looking at some existing discoveries. I think I'll go through some of these quickly. We've got some examples for seismics, looking at the comparative margin on the Brazilian side, and then looking into more detail in the Namib Basin at some of the recent data we've acquired, and a quick peek at this new Namibia data that we've had. It's just some of the fast-track data has just arrived back in our office in Weybridge, so just have a little bit of a sneak peek at that. Point in that direction. West Africa, it really got going in the early Cretaceous with the rifting that's been that really started off in the early Cretaceous, and we see the development of large fault blocks and a lot of rift-related sediments, lots of clastics input into the basin. It's this lake that has been talked about, a lot of organic-rich lacustrine mudstones, big anoxic lakes, and carbonates along the margins. As that rifting subsided, we get the development of sag phase sediments. These are really not as faulted. They lie on top of the fault blocks and the rift sediments, and a lot of associated carbonates related to these, and more anoxia, and we're really kind of just talking about this part of the West African margin. So blocked in by the Walrus Ridge to the south, and leading to quite a restricted environment, and this is kind of what led on to the deposition of the salt as the marine influence progressed. The stratigraphy for the Namib Basin is really not very well known. As I said, there's really only one exploration well. We can move north to the Kwanza, where we expect to see very similar stratigraphy. In the pre-rift, we see the clastics and carbonates that are so famous, the Bukumazi equivalent lacustrine sediments. Is where we're seeing our organic enrichment, the Toko equivalent carbonates. And then into the post-rift sections, where we see our salt, although this is largely missing from the Namib Basin. We still do see some areas of the basin that do actually have the salt itself, and into the Albion carbonates, this Bingo Pinder formation, these carbonates that form the rafts that we saw earlier, and then into a very thick succession of post-drift drift clastics. And this is one of the reasons why we're all here. The 2P discovery, this is a PGS Seismic Line through the air. We see our large tilted fault blocks towards the basin margin, the rift-related sediments associated with those fault blocks, and very thick sag, and the 2P discovery sitting on top of these fault blocks, and it's these microbial carbonates that we're excited about, and we're beginning to see now on the West African margin. Lula, or 2P, is here. It's the conjugate pair of the Namib Basin, As I said before, it's not quite a perfect pair, as the Namib Basin really lacks the same amount of salt that the Santos Basin. The continent-ocean boundary was far closer to the African margin in this part of the world. And I like to think maybe that the Namib Basin is more of an analogue of the Sergipe-Alagoas Basin, which is in northeast Brazil. There we see perched salt, like we see in the Namib Basin. And it's definitely worth pointing out that Petrobras have some fairly big, recent big discovery in that basin in some post-drift sands. And we see virtually the same structure in the Namib Basin. Back to the African side, this is the Cobalt Kamiya discovery. We see the Kamiya sits in here. It's on top of one of these fault blocks and the associated pre-salt sediments. So this is where we're seeing those carbonates. We can see the slight thickening on top of the basement. And more recently, we've got the Mavinga prospect here, which is actually, along with the Lontra prospects there, have just been announced as further discovery. So a little small, but we can see there's maybe 5 or 6 of these basement structures have been drilled, and they've virtually all been discoveries. So it's exciting. It's a little bit of detail on Kamiya 1 itself. Salt sitting on top of these pre-salt sediments. So this is where we see our reservoir. And this, there's a lot of oil in some of these basins. And some of these, I think it was Mavinga, had something like a 200-foot oil column. So they're still drilling. Having a look at quite a regional 2D seismic line across some of these structures. We've got the approximate location of Lontra. This is quite a large regional high, and you can just about make out quite a large regional high here that runs across this part of the Kwanza Basin. And the Lontra itself is actually pretty much at the peak of this large regional high, sitting on top of this fault block. You can see the Sin Rift. This it's about 100 kilometers, but we can see some of the sag and rift sediments. And the Kamiya discovery over here on a smaller fault block. If I zoom in on that, we see our salt in pink, and the Kamiya fault block with the position of those microbial carbonates, and quite thick rift and sag face sediments. So, moving on to the Namib Basin, we've kind of seen what happens in the north. I'm just going to go through some examples of some seismic lines and see kind of what we see in the Namib. This is relatively new data. This is broadband seismic. That we'll be looking at this 2D in purple here in this part of the Namib, and I won't get into too much detail, but there's a cable length of 10 kilometers, and we've had some various important processing steps there. And I'll be looking at the PSDM on the Namib Basin. So here's a typical seismic line from the basin itself. This is from the northern part of the Namib Basin. We see an extended continental crust pinching out to a sort of a transition zone where it's not all really that clear what we're looking at here, but we do see what we're happy with, the oceanic crust over here on the left-hand side. And on the continental crust, we see well-developed rift grabens. We see in the northern part of the basin, we see perched salt. There's in the region of about, I think it's close to 2 kilometers of salt, 1.4 kilometers in this particular part of the basin. We see volcanics in some parts of the basin, quite large stratotype volcanoes. These are, I think there's about 15 of them in the basin. And associated with those, and we see possible high amplitude anomalies on top of some of these volcanoes. We see things like these well-developed channel features and some of the post-rift, and things like high amplitude anomalies up against the salt. So there's a lot going on in this basin, and the sediment is very thick. So I mentioned that there really isn't any salt in the Namib Basin. We've got a strike line here coming from the Benguela Basin, where we do see the continuation of the thick Kwanza salt. As we move south into the Namib, this thick salt that we see to the north gradually pinches out. but we do have that area of perched salt in that small mini basin in the northern part of the Namib Basin. So there is still potential for salt in the basin. Here is that small mini basin. Well, I say it's small, still quite big. We've got it scale bar here, 20 kilometers, sort of up to 1.5 kilometers thickness of salt. But this is confined to a perched basin, as far as we can tell, in this part of the Namib Basin. So we see very thick cinerate fill capped by salt, and in this particular case, we're quite high up on the shelf, so relatively thin post-drift sediment, and all the associated channels and fans that you'd like to see. There we go. One thing we've done is mapped out the rift grabens in the Namib Basin. One of the concerns of this basin is that there's just very thin continental crust. We kind of tied down where we saw the oceanic continental boundary, and we're quite happy that there are a good series of these rift grabens. And I showed one of these earlier, but these actually are quite thick. They sometimes run up to about 5 kilometers thickness of sediment. And these are the kind of exact same structures that we're seeing further to the north that Cobalt is drilling. These are just further to the south. We would expect the same geology to be inside these lakes. It's still part of the same system. Got a couple more examples. That one was to the north. Here's one further to the south. I've got a base salt equivalent in here, as we've lost the thicker salt, but we're still seeing well-developed rift grabens, and to the south as well, well-developed rift grabens, and in this particular case, something in the order of about a kilometer of nice onlapping post-drift sediment into some of these sections. Keep skipping. So the volcanics. There are volcanoes. It's a unusual feature for the Namib Basin. Here's a good example that shows a few of these. Most of these are associated with late rift phase. We can see this particular example. We see a nice, well-developed rift graben with a sort of double volcano sitting on top, which kind of tails down to some smaller ones. And there do appear to be multiple stages of volcanism that come up into the early post-rift sediment. So we can kind of see some of these nice flanks of these volcanoes. In this particular case, you can see we do clearly have a bit of a time separation here. There's an awful lot of sediment in this basin. I have a strike line here that runs sort of on the outboard most western part of the basin. In the southern part, it's up to about 6 kilometers in this particular case. It thins to the north, but we still have in the region of sort of 4 to 4.5 kilometers of sediment. And looking at oil and gas windows, certainly further up onto the shelf, we'd estimate that a lot of these rift sediments, sag sediments, early post-rift sediments are in the oil window. One of the things that we've looked at as part of the work that we're doing is we've remigrated some of these lines down to about 30 kilometers to get more of an idea of kind of where that ocean continental crust boundary is. And these lines really nicely pick up the base of the continental crust, thinning out, as you would expect, into this transition zone, which is often associated with volcanoes, and then nicely defined oceanic crust, sort of base of the Moho here, kind of roughly about 10 kilometers. It's not going to go. Oh, there we go. So, just a couple slides here on the new Namibia data. This is now we're south of the Walvis Ridge, which is sitting here. PGS shot a survey here in pink. We also have some data on the shelf here, and this is an area of sort of active interest at the moment. There's been some recent wells, particularly by HRT. Although there weren't any discoveries by HRT, they did reduce the risk of the basin. In particular, the source rock was actually being one of the biggest risks of this basin. They did find, they claim they found 2 working source rocks. We assume it's an Aptian source rock and a Cenomanian Turonian source rock. And it's also kind of interesting to see that Tullow are now kind of farming into some of these more shelfal blocks. This is, I have a line that I will show in a second, but here's some stuff from HRT that really, I think, has reduced the risk of the basin. I mean, I mentioned they found 2 well-developed source rocks within the oil window. Their first well, Winget 1, which was I guess you could call their biggest success. It didn't actually, wasn't really a discovery, but they targeted this carbonate platform. And although they claim that what they found when they hit that carbonate was a lime mud, it's still good to see that they did actually find a carbonate. They also found those 2 source rock intervals, which is very interesting. And they actually found light oil of sort of 3842 API in some sands below some of that carbonate. So there's clearly proven now a working source rock in the basin. And they actually confirmed that these source rocks by 2 more of their subsequent wells, Morumbe and Moosehead further to the south. The Winget, this is that carbonate that Winget was targeting, these high amplitudes. At this point, there were those lime muds. I mean, you can see further to the west here as we go offshore. We can see progrades here, which could possibly be the reefal carbonates that I expect that they were hoping for. And it was this interval in here where they claim that they found their Aptian source rock. And that interval we've traced out, and we can kind of see it extending off into the deep water. So that Aptian interval in Namibia is actually just sits above the Sin Rift. So it's quite extensive and is related to the oceanic anoxic event. And they also claimed they found a Cenomanian Turonian source rock, or that's what we believe it is, above this interval, which again is traceable throughout the region. Come on. It's not having much luck with this. There we go. Okay, so here's the first fast track. This is a geostreamer GS line. This is just fast track. We've got this into the office recently. And this is a very regional line. It runs pretty much from almost the coastline, very much into deep water. This line runs just to the south of the HRT's Winget well. I'll zoom into this area a little bit later on, but that carbonate was sitting up here. The Aptian source interval sits just below this. On top of this well-developed Sin Rift, in here we have faulted basement sitting underneath here. Nice thick post-drift sediments with multiple channels all the way through. And that gets out onto oceanic crust out here. And this line shows a lot of this Sin Rift interbedded with SDRs. And the SDRs seem quite variable along this coastline. And in some lines we have a fraction of this amount, so that's definitely intriguing. Just zoom into this area on the top right. So this was the position of those Winget carbonates. The carbonates are these high amplitudes sitting up here. That Aptian source rock interval extends right up to the point where the Sin Rift pinches out on top of the basement. In the deeper water, there's just channels and fans everywhere you look, really. And these sit on top of these Sin Rift sediments and these well-developed SDRs. So, just to kind of tie up, I think we're all keen to get to the pub. So this is a very kind of frontier area. So this kind of regional seismic is really good at kind of looking at the prospects and the prospectivity of these basins. And I think that this broadband seismic really helps that along. And there's clearly a lot of prospectivity in this basement. There's an awful lot of sediment to be explored here. And I think the future looks pretty good. And I think as companies come in and start developing this region, I think we'll reduce the risks significantly. Yeah, so thank you very much.
Thank you, Craig. No problem. Right. we really do have some time for questions, and it'd be lovely to have some. This is real frontier areas now, so we're beyond the control that we've looked at in the basins to the north. So are there any questions? There's one here. Sorry.
Hi, Rob Crossley from Robertson's. You commented on the very variable nature of the SDRs. You didn't really tell us why you thought they were so variable.
I honestly couldn't, I haven't really looked into all that much detail. I mean, as I said, we only got this last week and we fast-tracked, I think 7 or 8 of these longer dip lines. And as we're kind of going through those, we've just kind of noticed this. And on the particular example I showed you, they're quite extensive. In some other areas, they're probably maybe a fifth of that size. So my feeling is in that particular example I showed that maybe there's actually quite a lot of synrift or sediment incorporated in with those. There's obviously multiple stages of SDRs. So my feeling is there's probably quite a lot of traditional normal sediment, clastic sediment incorporated in a lot of that in this particular case.
Okay, thank you.
This one up here. Question?
Is there another question?
Yes.
Thank you. On Namibia, I mean, Chariot also drilled 2 wells. Would like to comment why Chariot and the HRT failed.
Why they failed?
Yeah. Thank you.
I think the Winget discovery failed because I think they hit the wrong carbonate. I think hitting a lime mud, I think is clearly their reservoir was their main failure. They were actually pretty happy that they were going to get great reservoir quality in these carbonates, but they obviously didn't. What it did prove, on the other hand, was that there was good source rock. I think the Marumbe well failed. My feeling is that their main target, a deeper top synrift, was probably a volcanic, and they drilled through their secondary target was a fan system in the early post-rift. My feeling is that it was probably trap was the main reason for that failure, and potential migration issues from an aptine source rock into some of these overlaying fans, which to me is kind of one of the biggest risks.
There's another question here. Thank you.
Hi, Andy Hopkins. On the GTEC presentation, there's a big gap on Namibia for rivers. There was nothing much coming in. Do you have enough sediment input points along the Namibian margin?
I would say probably, looking at the amount of sediment that we have, I think you're right in that we don't have a single point source for a lot of this margin, but I think we have enough sediment thickness in the basin not to worry about the amount of sediment that we have. And actually looking at a lot of the margin, especially from the Namib, we're looking at fairly good quality sediment. I know there's a lot of volcanics in parts of Namibia, but there's an awful lot of decent quality sediment there for classic reservoirs.
Yeah, coarse enough?
Well, you maybe. I think if you're kind of looking at short enough transport distances, you might be okay.
Yeah. You don't really see a lot of sediment till you get to the Orange River, do you? To the south.
Down there, you get an awful lot of sediment.
You get a lot
I think
down.
there's enough in Namibia that will put things into the ore window, assuming they didn't go in the Cretaceous.
Duncan McGregor again. What always worries me about Namibia compared to what we see in Jubilee, something like, is the lack of an obvious bypass zone. Can you show us or tell us of an obvious bypass zone in that shelf?
I'll catch up with you maybe later.
Good answer. And there was one here, where Nigel, yeah.
Yeah, Nigel Quinton Tower. Just on the Namibia reservoir potential. I mean, the early wells during the 90s, the problem they had was lack of seal, not lack of reservoir. The quality of the Cretaceous sands is exceptionally good. The Ranger well that I was involved with through Hardy, we would basically sand from top to bottom. So there's no shortage of sand going into the basin. And the Chariot well to the north, just to the north of the Walvis Ridge last year, 173 metres of Cretaceous sand. And you even get sand right out into DSDP holes 100 kilometres west of the outer high that our prospect is located on.
Thank you. Nigel? Any comments on the source rocks? I mean, I remember when looking at this area, it was the one thing that kind of worried me, but there's really no reason why there wouldn't be Apto-Albion and Turonian source rocks here.
Can I come back on that? I mean, the North Kedra wells, very, very high quality source in those two wells. Those are the two wells just south of the Walrus Ridge.
In the late Cretaceous?
In the early to late, basically
Okay.
from the, essentially from, there's an Albion carbonate, which was cored in one of those wells. That had a very, very light remnant oil in that core, in the tight stuff. There's biomarker data in there that suggests that came from a synrift source, which is interesting. Very, very small sample size, but you know that's what the geochemists tell me is what it's telling us. The post that you've got 4% TOC, pretty much through the lower part of the Cretaceous there, going up to 10% TOC in the Cenomanian and even up into the Santonian. So that whole section is source prone in those wells. Of course, the wells to the south didn't see that because they were more shelfal. They didn't get into the basin. And it's only the HRT wells now that have really sampled that same basin location. Can I ask a question on your comment about the HRT results? We're still unclear where those two source intervals are. They call them mature. It's hard to see the Cenomanian Turonian in Winget being mature. So we rather suspect that those two bands are two separate intervals that they are identifying.
Yeah, they do. On one of their investor presentations post-drill on Winget, they did actually indicate their kind of two zones further down dip, and it is quite difficult to get anything that might be the Cenomanian Turonian, as there's a bit of a slump, I think, just to the west of that Winget carbonate.
Indeed, you've got an oversteeping shelf. Yeah.
Very difficult. We've kind of been able to trace it around using some of our in-house seismic. But
And you said you can trace those banded sections well across the basin, because we see that on some of the lines we've got, but we don't have quite the same database.
Looking at that, we've looked at that Aptian subcarbonate layer quite extensively, and then we can map it everywhere.
Yeah.
Really, it's pretty extensive. I mean, on some of these lines, it goes far, far, far into the deep water, which would make sense. I mean, this is rifts slightly earlier than basins to the north, so at this stage, this was all deep water, open ocean. So.
Thank you. Okay, thank you very much.